Okay, we're going to wrap up this learning target. So, we figured out what the force of B on A was. It's 29 newtons, and that's going up. B is pushing up on A. And then we want to know part C here, what is the force exerted by block A on B? Well, they are an action-reaction pair, okay? And so that means it's equal and opposite in magnitude. And so equal magnitude, 29 newtons, opposite in direction. So instead of going up, it's going down. All right, now we had to look at this situation here two different ways. So I drew the individual free body diagrams here. And then I also looked at this as if they were one object. Because when we're pushing this along, the blocks, they don't separate. Okay, so they're going to be going the same acceleration. They're going to be moving with one another. So if I'm going to treat this as one object for a moment, then that was what my free body diagram would look like. I'd have some force due to gravity, some normal force, and then I have an applied force of 20 newtons. So in the x direction, and really these cancel as well, so the sum of my forces is just equal to 20 newtons. Okay. And then the mass is 3 kilograms plus 2 kilograms, so that'd be 5 kilograms, and then we're looking for the acceleration. Okay. So I have 20, and then I want to get acceleration by itself, so I'll divide that by 5, and so acceleration is equal to 4.0 meters per second squared. Okay, so now that I know that acceleration, I can go, what is the force of the 3 kilogram block, which I labeled B? So what is the force of B block acting on the A block? So what is the force of the B block acting on the A block? So that's what I'm looking for right there. Okay. So now, if I'm focusing on this free body diagram, and I'm just going to look in the x direction here, I would say the sum of my forces is equal to a positive 20 newtons, and then I'm adding that to a negative force of B on A. Okay. Now, we can figure out what this sum of the force is in the x direction for that object because I know A. The sum of the force is equal to the mass of that object. Okay, and again, we are looking for the force of block B on block A. So we're looking at block A here. So that would be 2 kilograms mass times by acceleration, which is 4 meters per second squared. So that would be 8 newtons. Okay, and so we have 8 newtons is equal to 20 newtons minus the force of B on A. We want to get this by itself. So what if we add this to the other side and then we subtract that? So the force of B on A would be 20 newtons minus 8 newtons. Okay. And so then that would be 12 newtons. Okay. So then what is the force of the 2 kilogram block on the 3 kilogram block, or what is the force of A on B? Well, A on B, the force is equal and opposite to that. So it's still 12 newtons, but this time it's going to be to the right, where before it was to the left. Maybe we'll write that in, because the force of B on A was to the left, and this is to the right. Okay, ropes and tensions, I decided as I was looking through this that we're going to skip this part, this last little part of the unit here. So we're not going to be worried about reaction pairs with ropes and tensions, and you won't be seeing that material on the exams. Okay, guys, so that wraps up this lecture for this unit, and then the next day we have the lab that you're going to be completing.